Oxidation of alcohols are a set of reactions you need to know for OCR A Chemistry. And today, I will be walking through the different classifications of alcohols and the reactions of these variants with an oxidizing agent. There are three different classes of alcohols: primary, secondary, and tertiary. And difference between them is the number of hydrogens and of alkyl groups connected to the carbon that is bonded to the alcohol functional group. Primary alcohols are alcohols with two hydrogens and one alkyl group connected to the carbon that the alcohol functional group is connected to. Ethanol, which is this molecule right here, is a primary alcohol because the carbon connected to the functional group is also connected to two hydrogens and one alkyl group. Secondary alcohols are alcohols where the carbon attached to the functional group is also attached to two alkyl chains and one hydrogen. An example of such a molecule would be propan-2-ol. Tertiary alcohols are alcohols where the carbon that is connected to the functional group is also connected to three separate alkyl groups. An example of such a molecule would be 2-methyl propan-2-ol. For the exams, you must be able to spot all three different structures to predict how they will react in the oxidation reactions. Primary and secondary alcohols can undergo oxidation with the aid of an oxidizing agent. The oxidizing agent is a mixture of potassium dichromate acidified with dilute sulfuric acid. The oxidizing agent, potassium dichromate, is written with Roman numerals. The 6 in Roman numerals represents the oxidation state of the chromium atoms in the dichromate ions, which are written as so. When an alcohol is oxidized, the dichromate ions are reduced to chromate ions. It is important to state that the dichromate ions have an orange color and the chromate ions are green. Hence, chemists can spot if an oxidation reaction has occurred by looking for a color change. There are two possible reaction pathways for primary alcohol, forming two different chemicals. The primary alcohol can be heated gently with the oxidizing mixture using a distillation apparatus to form an aldehyde and water. Aldehydes are homologous series that have the functional group CHO and are drawn as so. If the aldehyde product is not distilled out, it may react further with the oxidizing mixture, forming the other chemical, a carboxylic acid. You can force this reaction by instead using a reflux apparatus and vigorously heating the primary alcohol with an excess of the oxidizing agent, forming water and the carboxylic acid. In summary, if you're aiming for the aldehyde product, use a distillation setup. If you're aiming for a carboxylic product, heat under reflux with an excess of the oxidizing mixture. Secondary alcohols react with the oxidation agent to form water and a ketone. Ketones have functional group CO and are drawn as so. The oxidation reactions for secondary alcohols should be carried out under reflux to ensure the reaction goes to completion. Tertiary alcohols are actually unable to undergo oxidation reactions under normal conditions. If you try to oxidize a tertiary alcohol, the oxidizing agent mixture will remain orange.